Hi guys, today we are going to discuss system design hacks and one of the concept which is the scalable expiry events or triggers. So we will look how it is applicable in different scenarios. And what are the solution we can use. So here one of the scenarios is cab booking, another is job scheduler, third one is meeting notification. So we will focus on the cab booking and similarly it will be applicable for other tools also. So let's take the example of cab booking. So as a customer or user of a cab booking system like Ola or Uber, we make the request to the Ola Uber and it figure out the nearby drivers and it gives the request to them. And once the driver accept it, they move towards the pickup location of customer and start the trip. So the thing is, when you are going to when you are finding these nearby drivers, so it may be possible same driver can appear in a different request. For example, two customers are making the request to the system from nearby locations. Uh, Suppose we are taking example of X1 location. So both customer are nearby X1 location. They are making the request to the Ola or Uber. So once Ola Uber will fetch the drivers who are they are available nearby that location, they will figure out driver one or driver two who are there. Only the concern is suppose we are making giving the trip to driver one basically as an offer. So driver can accept the offer or reject the offer. Two possibilities there. If he is going to accept it, so he will start moving towards the pickup location and start the trip. The thing is, suppose for these two cases, suppose for both cases, driver one is eligible and we are going to give multiple offers. So obviously, his app will getting bombarded with the multiple requests, and he can only accept only one. So to avoid giving the multiple offer to same driver, what we can do is we can capture the intermediate stage, like we have already given the offer one to driver one, and we can keep in our something kind of Redis for suppose 60 seconds expiry. If driver is not going to accept in 60 seconds, so key will expire. So if any for any other offer, he will be eligible. Okay, so this kind of situations we can handle through this uh, expiries, matlab keeping the cache with the TTL time. So that is very helpful for those scenarios to avoid multiple offer, giving the multiple offer to same drivers. And similarly, the next request, when we are making request, we will checking the cache. If we have already given any offer in last 1 minutes to driver one, then obviously we will ignore driver one and we will go with the other drivers. And then we will send the offer to other drivers. So this is how we can handle the situation. So this was the first scenarios where this scalable expiry event triggers events or triggers is helping to avoid those kind of situations. So there is little bit blur line between the all three cases, like the cab booking, job scheduler, and meeting notification. Let's try to focus on the job scheduler part. When we are going to focus on the job scheduler part, then you will realize when we are scheduling a job. So scheduling a job, for example, job one is there. Okay, and job one, it can be, for example, a one-time event or it can be a redundant event, recursive. So, for example, if I'm saying it is a one-time event and it will have to trigger at T1 time, this job instance we can consider job I, for instance, and 1. Okay, at T1 time. What we can do is we can use the Redis as a solution, or here not only the Redis, any other cache also we can use, which gives the this thing, the TTL thing, and where on TTL it can emits the event which we can listen and performs whatever action we have to perform. For example, for this scenario, when T1 times will, so suppose I have to schedule this job at for T1 time. What I will be doing in expiry I will TTL will be equal to now current time, basically the now minus T1 time. Okay, that much seconds or milliseconds we can say, that will be our TTL time will in our system, which we are going to provide in Redis key value and the this TTL time. So once the TTL will get expired, it will emit a event, and we are going to listen that event, and on basis of that event we will perform the action. Suppose this whatever execution, suppose this job is generating files or something else, like sending a notification or something, we can perform that. Now the thing is, it is one time event. Okay, suppose it is a repetitive one. Suppose every Monday, uh, 10 o'clock in the morning, I have to send some notifications. So, how this is a job. Okay, so what I will do, once I will put the first instance, suppose that is the T1 time, and once that this TTL will get expired and the event will trigger. Okay, at that moment I will handle the sending the notification also, and along with that I will add next instance of the job in my Redis cache. So this is how we can handle it. So this is a, because we are using the distributed cache system here. Redis is a distributed cache system, so it will be scalable, and for any scale it will able to handle it properly. So this is how we are going to perform this thing. The I'm not going to focus on the other concept around that. I'm just focusing how we are utilizing these expiry events or triggers to perform those kind of actions. Even like for first case, we are using for keeping in cache with some TTL to avoid giving the multiple offers to same driver. Similarly, in job scheduler, we wanted to perform some action, and it should be performed at same moment when that this T1 time is scheduled for. So that's why we provide the TTL, and on the key expiry, we are performing the action. Similarly, the meeting notification. Suppose if you look the Google Calendar, so you get the notification before 30 minutes for this meeting is scheduled in next 30 minutes. So how you are going to get those kind of things? So similarly, like how we did for a job action, whenever meeting is created, or the whenever we are pulling the meetings for next day or something, what we can do is we can add the timestamp when we have to trigger the notification. Suppose we will provide a key notify for next 30 minutes. That is the key, and the meeting ID will be there, and the TTL time will be there, and TTL will be suppose it is scheduled at T1 time, so it will be TTL will be now minus TTL T1 minus 30 minutes. Okay, it will be something like this 30 minutes. Now you will able to get the trigger event before 30 minutes of the meeting, and it will you can send the notification through the mail or something, or some other way like SMS or something, uh, to the user ki your meeting is scheduled for this time in next 30 minutes. Okay, so this is how we perform the action. So these kind of things, using the distributed cache with the TTL, it helps with lot of places. I took the only these three example. It may be applicable other places also. So I hope you will get to learn more, and you will figure out more use cases where you can apply these concepts. Thanks, folks.